All right, everybody. So today we are looking at symmetry and how it applies to graphs in the coordinate plane. All right, ladies, gentlemen, I understand it's Friday. We're all very excited. Stick with me and we'll be done before you know it. But I do need your attention. Okay, so check it out. I know you know what symmetry is. Like a butterfly has vertical symmetry. If it folds its wings, they match up. Heart shape, same thing. You go down the middle, you go fold it in half, they match up. So I know you're familiar with the concept of symmetry. So why do we care about it when we're graphing? Well, graphing is a tedious process. So if I find out that I have a graph that has some symmetry, oh, well, now if I can figure out one piece of it, I can get the other piece for free. So it takes a lot off my plate. So let's take a look at what's going on here. Let's look in this first box. What does symmetry look like? So if you take a look at the first graph, here's a graph that we would say has symmetry over the y-axis. So if you literally were to fold your paper on the y-axis, those two pieces of the graph would match up exactly. You agree? Perfect. Then we have symmetry over the x-axis. If I were to fold along the x-axis, literally take my paper and fold it, these two pieces would match up exactly. And then you can also have symmetry over the origin or any other point. It doesn't have to be the origin. So if it's over a point or the origin, look what you're basically doing. You're folding twice. And it doesn't matter which way you fold first. So if you fold it along the x-axis and the y, can you imagine that these two pieces, you would actually do it if you want. If you want to take your paper and fold it twice right here, you should see that this branch would fold right on top of this branch. Okay, do you see that? Can you follow that? Okay, cool. So how do we know? If I don't have a picture, because seeing with a picture, it's pretty easy to tell if I have symmetry or not. What if I don't have a picture and I'm just given some equation? So here's how we're going to test down at the bottom. Here's our steps. Okay, so if I want to test if something has symmetry over the y-axis, I'm going to replace x with a negative x. And then I'm going to simplify what I have, and I'm going to check, are the new equation and the original equation the same? If they are, then yes, I have y-axis symmetry. That's all I have to do. And can you see why that would be the test? So let's look back up here. So let's say I have some point right here. It matches up with this point over here. Aren't those 2 points exactly the same? The only difference is that instead of a positive x, I now have a negative x. Do you see that? So that's why that's the test. Replace x with a negative x and see if I get the same equation. So naturally, you can see I'm doing the same thing to test for x-axis symmetry, except that I've replaced y with negative y for the same reason. So if I take 2 points that correspond on this one, maybe this one right here matches up with this one right here. They're the exact same point. The only difference is that this has a positive y and this has a negative y. You see that? So if I make that swap and I simplify and I get the same exact equation as the original, I know I have x-axis symmetry. And then to test for the origin, you could probably have guessed we're just going to do both. I want to swap x and y with their opposites. Simplify and see if I match. Okay, and if you follow in a, let me do the same thing. So if I picked right where this bends here, that would match up with this right here. So these are going to be the same point. It's just I have, instead of positive x, positive y, I have negative x, negative y. Okay. All right. So if you look on the back, there's a few for us to try. So we'll do some together. And sort of, it's a little bit of a bummer because there's not really a shortcut. Like if it has x and y symmetry, it doesn't automatically have, oh wait, no, I take that back. If it has x and y, I wouldn't need to test for, oh, would I? question. Now I've stuck myself. I guess we'll investigate. Okay, so let's take a look at number 1. If I want to test for x-axis symmetry. Let's sort of see how we work this out. So here's my test. So remember, for x-axis symmetry, it says on the other side we're supposed to replace y with negative y. So let's try it. Negative y equals negative 4x plus 1. Okay, I want to simplify this, so I always want my y to be positive. I could divide everybody by a negative 1. I get positive y equals positive 4x minus 1. Does that match my original exactly? No, it does not. I had a negative 4x and now I don't anymore. And the positive and negative 1 have swapped. So no, I do not have x-axis symmetry. Let's try y-axis. So in order to test for y-axis symmetry, I plug in what? Negative x. If I simplify this out, I'm going to get a positive 4x plus 1. There's no other simplifying I can do. Does that match my original exactly? No. So I do not have y-axis symmetry either. And I'll see if I can squeeze it down here, see if I have symmetry about the origin. And how do I test that again? Yes, do negative y and a negative x. Now let's simplify this equation and see if it comes out to match the original. So I get a positive 4x plus 1, and now I have to divide everything by a negative 1. Does it match? Nope. This one doesn't have any symmetry. Too bad, so sad. Let's try the one below it. Okay. Doesn't matter in what order you go in. I'll try x-axis first. You try it too. We'll see if we end up in the same spot. So, do we have x-axis symmetry? No, I'm close, but it's not. Nope, the signs are off. Right? I have a -5 and a positive. So yeah, nope. I do not have x-axis. Let's try for y-axis. Something's got to work at some point. Try it. Actually, before you try it, or in the middle of you trying it, do you see how I wrote this? Look what I did. I took this exactly, and I'm replacing just this x with a negative x. Since it's negative, I put in parentheses. So now it's kind of up to you to make sure that you evaluate that correctly, or simplify that correctly. This right here. How should that look? Hopefully, you got that this does have y-axis symmetry. Did you? Okay, so it all comes down to if you're evaluating this correctly or not. You have to do, there's nothing to do inside this parenthesis, right? There's nothing to do in there, but I do have an exponent, so that comes next, according to Dear Aunt Sally, right? So parentheses, nothing to do inside of it, but now I have to do the exponents. What is negative x squared? What do you get when you take a negative x and you square it? Positive x squared, right? Negative x times negative x would now be a positive x squared. I am still going to subtract that. So I have 5 minus this chunk right here, just turned into a positive x squared. And ta-da, that does match my original. It's exactly the same. All the signs are the same. So yes, this thing does have y-axis symmetry. Cool. All right, now let's just check for symmetry over the origin. Remember, you're plugging in a negative x and a negative y. So be careful in how you're doing it. Just replace the x with a negative x. So double check that you, when you replace that negative x, that you wrote it just like I did. And now it's up to you to evaluate this and see if you can make it match the original or not. So what do you say? Does it have symmetry over the origin? I'm seeing some no's, and I agree with you. If I fully simplify, this is where I get to, and that does not match my original. So it's a no on the origin. How do we feel? Let's do one more together. You pick which one out of the 4 that are left on this sheet. Which looks the worst? Raylan? Okay, the 2 absolute value ones? Yeah. All right, let's try it. Do you want me to let you try it by yourself first? No, just do it together? All right. I mean, whatever you guys want. Okay. So if I'm going to do x-axis, I am going to plug in negative y. Well, the absolute value of negative y would just be what? Yeah, it would just be y. Ooh. So I guess does that technically? Yes, yeah, because you can do this. When you have an absolute value, which you can do, you can split it up like this. I could, instead of writing it as negative y, you can write it as negative 1 times y. You can split up an absolute value, that's multiplication, and that's, you still have the same values there. So the reason why I'm doing, I know you're just like, why don't you just write y? Because my original had absolute value y. So if I just write y, then I can't like invent an absolute value. Could you? I mean, it's not wrong. I don't know. I like this way because I can definitely do that. The absolute value of 1 or negative 1 is just 1. So now it's gone. So now, yes, I do have it right back to the original. There's a yes. I do have x-axis symmetry. So you could, but it's not going to help you because you want it to look like this. You know what I mean? It's not wrong, but you're doing more than. Oh, no. And wait, yeah, so now I'm going back on this. Yeah, you couldn't just call it X and Y. Yeah, no, you can't do that because then if you just, then you're taking away the negative part of it. Then you're just assuming that X and Y are always going to be positive and they may not be. but I could still have, like, if that's -1/2 and that's -1/2, it still adds up to be a +1 if the absolute values are there. If you take them away, now you're gonna have -1/2 plus -1/2, it's not gonna equal a +1 anymore. You can split it up, yeah, you can like, so if it was like 2x, you could split it up into an absolute value of 2 and an absolute value of x. That's allowed. But I couldn't, because I can take the absolute value of a number because I know what that number is. I can't take the absolute value of the variable because I don't know if it's going to be positive or negative. Okay, let's try y-axis. So y-axis, we pretty much know we're going to do the exact same thing, right? The same thing's going to happen. I have -x plus absolute value of y equals 1. I can do the same, sort of play that same game. Separate that, -1, absolute value of x, absolute value of y. So now I just get absolute value of x plus absolute value of y, which matches my original. So that is a yes. And I'm fairly confident, I will double check, but I'm pretty sure if it's yes over the x and yes over the y, it's got to be yes over the origin, right? Because you folded it twice. So we don't even have to test for over the origin. It should automatically be a yes. So if you have yes and yes already, it should be yes over the origin. Origin? Yes. That's already over both. Origin is okay. Or is too, let's say that. Thoughts, questions, comments, worries? You sure? Okay, so I have another sheet I'm going to give you. And I think we should, these sort of have a little bit different style questions for some of them. So let's do a few. That's it. Yes. Yes. Just wait for me to get that, so. Here's the next one. Okay, Henry. Okay, so very quickly, I just want to do, these have a bit of a different style to them, some of these questions. So, number one, real quick, if you had a point that was 1,3, and you were going to reflect it over the x-axis, what would its new ordered pair be? Jonas? You got it. Because remember, if we're reflecting over the x, we just change the y. So then over the y-axis would be -1,3, and then over the origin, you got it. So first section, nice and easy. let's take a look at number 4 is basically the same thing for the, yeah, because the point M that you're talking about is the origin. So it's the same thing as reflecting it over the origin. But 5, things kind of change a little bit. Let's check out 5. If I were to, I'm just going to graph it. If I had 5, 4, that's where point Q is, 5, 4. And now you're going to reflect it over the point M, which is at -3, 2. So here's M at -3, 2. So if I'm going to fold my paper over and I'm going to spin it, like you got to almost pretend that that's the origin. Can anybody figure out where point, usually we call it Q prime. So it'd be somewhere over here. Somewhere in this region is going to be my reflection of Q, which I'll call Q prime. Anybody think they know where this is going to be? Go ahead.
Oh, not 8.
What'd you do? Look at the Y's. You went from 4 and now you went down to here. So you're going to do the same thing. So if you went from 4 down to 2, you're going to keep going down to, yes, 0. How'd you get the -11?
I went to the left 5 to get the Y back. The left 3 more to get up 8. So.
Exactly. This is the same thing. Like I could ask you the same question as, remember, did we do that with the midpoint? And I said, yeah. So if you pretend that that's the midpoint, where's the other point? And we had that cute little shortcut that we were like, okay, well, I go from 5 down to -3. So that's subtracting 8. Let me subtract 8 again. And I land here. I do the same thing with the Y's. I was at 4, I went down to 2. So that's, I subtracted 2. Let me subtract 2 again. And I end up at 0. Oh, cool. 7, all you have to do is draw it. So what do you think that's going to look like if you reflect that over the x-axis? So remember, that means that you're folding the paper along whatever line they're talking about. So if you folded the line along the x-axis, what would it look like on the other side? What's the other piece going to look like? Did you draw it? Hopefully you drew something like this. Right? Because if I fold that x-axis, this is the piece that would match up. I didn't do a very good job, but let's just do 8 while we're at it. So if this is going to be reflected over the y-axis, where does that go? Yeah, you're going to go this way. So it looks like an M. I didn't do it very specifically, but I just want you, like, if don't put it down here. Oh, and what if you did it over the origin? Do I have one when I ask you to draw it over the origin? Oh, yay! You try 9. Can you draw it over the origin? So you got to imagine folding that paper twice. You're going to fold it on the X and the Y. Where does that thing end up? Did you do that? Or something very close to that? Okay, cool. And it doesn't matter which way you go first. If you fold it over the X first and then the Y, or the Y and then the X, it doesn't matter. We're all going to end up in the same spot. Ooh. 10, we might as well do this one together because I know you're like, oh, what do I do with this one? First of all, where even is the line y equals -1? What is that? If you had to graph the line y equals -1, where is it? What is it? Evan?
It's a horizontal that goes through 0 and 1.
You got it. It's this line. I'm going to put it as a dashed green line. There's the line y equals -1. So again, that's where you're folding the paper. If I want it to be symmetric about that line, I'm folding on that line. So imagine you drew this curve and or you imagine you painted it and then you folded it over. Where's the paint going to show up on the other side? Draw what you think it looks like, and then we'll look. Try and be really specific with this point. So plot that well, like where does this one end up when you put that over? Evan, where's it go?
So it's like a curved line, like one below.
Here?
Yeah.
Yes.
And it goes like all the way down like that.
Then it goes somewhere like that.
Yeah.
I mean, you could track each point. I'm being kind of lazy here, but see how it folded over? None of them ever touches the green line. It doesn't actually touch it in this case, and that's fine. How interesting. Isn't symmetry fun? See, I knew you would enjoy it. And then the bottom, you know how to do that because we've already looked at it. So you've got about 12 minutes. Yes, okay. I think that that's a reasonable, I would like you to complete the front and back, whatever's left. I will open it up on Jupyter so you can submit it when you are done. If you have any questions, let me know. Wow. Everything where it belongs for once. This is not like me, but I'm trying.
So.
Yeah.
This.
Yeah. When you do negative x squared, you're gonna have negative x times negative x. Then you have 3x squared. Yeah. Does that make sense?